Well, good afternoon, folks. Thank you for joining us for the Iowa Learning Farms Conservation Webinar Series. I'm Liz Ripley, the Conservation and Cover Crop Outreach Specialist with the Iowa Learning Farms. We're based on campus here at Iowa State University, but we're thrilled to have some folks here from the University of Nebraska-Lincoln to share with us information and research updates on their evaluation of diverse cover crops across Nebraska, findings from spring and fall planted cover crops. And to present that information, we have Grace Pacheco, a former master's student at the University of Nebraska-Lincoln, and Vesh Thapa, a postdoctoral research associate. So with that, I will turn the virtual floor over to you all. And at any time, if folks have questions, feel free to submit those in the chat, and we'll get to the Q&A portion after their presentation.
Great. Thank you, Liz, for that introduction. Good morning, afternoon, everyone. My name is Grace Pacheco, and I'm very excited to be here and share with you a little bit about all of the work that we've been doing over here in Nebraska. So without further ado, let's just get into it. Okay. So a little bit of what to expect throughout this webinar. We're just going to give you a little bit of a background of the project, what we've been doing over here and why it came to be. And we're also going to share a little bit about the methodology we use, like the sites, planting windows, and all the cover crop tests that we evaluated. And last, we're going to share some results, mainly top performers and by season and location, and also just like some patterns that we found. And last but not least, we're going to share some take-home messages right at the end. Okay, so to give a little bit more feedback about Nebraska, we're neighbors. You guys know us right next to each other, right? And the thing with Nebraska is like we have very different agro-eco regions or agroclimatic zones. And we mainly decided, at least for this particular project, to divide it in eastern, central, and western Nebraska, with East Nebraska having higher precipitation with longer growing windows and fine or medium texture soils that have very high fertility and water availability. Central Nebraska, we normally have moderate precipitation and diverse soil types with moderate fertility. And the western part of the state, we unfortunately have very limited precipitation, short growing seasons, very harsh winters, and coarse texture soils with low fertility, and we do suffer some water scarcity. Now, this doesn't stop. Nebraska is a very well-known agricultural state. We're the fourth state for total agricultural products and the fifth state for grain produce. And out of the 8.6 million hectares that are under cropland operations, 47.7% are under corn, 24.4% are under soybean, and 4.7% are under wheat. And this is important because it kind of shapes the crop rotations that we see here in the state. So we have two main ones. We have corn and soybean rotations, and we have the corn, soybean, wheat rotation. And as you can see over here, we also have all this months and this periods throughout the year where if we're not planting something such as cover crops, they're just like fallow. It's like very gray. If you can see that how at least in this graphic, it really does changes once we are adding cover crops. But it also brings a question, okay, if I want cover crops in this windows, when should I be planting? And this is how we kind of come with this idea of having an early spring planting, especially in like the western part of the state that has very harsh winter. And because of the short growing season, it doesn't really give us time or to our producers to plant cover crops in fall. Then we have the fall planting, which is normally around September or early October. And finally, the summer planting, which tend to be right after wheat harvest or the winter wheat harvest, sorry. And now, but why should we be adding cover crops to our soils? Well, cover crops do have a lot of benefits, and they start with reducing soil erosion by reducing aggregate detachment. They provide a cover. They anchor the soil with roots and also help reduce runoff. They help with managing nutrients by reducing nitrogen leaching and erosion. They increase carbon sequestration. They fix atmospheric nitrogen, especially legumes. And our grasses are very well known for scavenging nutrients. They also promote plant and microbial diversity by providing habitat for beneficial insects. They increase population of soil, macro, and microorganisms. And last but not least, it has studied that cover crops do help enhance soil water storage by increasing water infiltration, lowering soil temperature, and increasing aggregate stability. Now, cover crop adoption in Nebraska overall, it's still very low. We have currently around 4.4% of cropland area is under cover crops, and this has been like increasing over time. In 2012, we had around 7%, like 0.7 million acres. That increased 7.2 to 2017. And then by 2022, we had an increase of 24% of cover crop adoption. And the adoption patterns that we're seeing in the state is we have higher cover crop adoption in the eastern part of Nebraska rather than West Nebraska. We also have some challenges, which is normally like the planting window and late crop harvest, input costs, such as like the seed costs and the labor that it has to do with like cover crop. And the last but not least, but we still have some motivator factors such as cost sharing funding programs and personal land stewardship. So it's like how all of this farmers and producers that are caring more about their land and they're like, how can I help my land last longer, right? Or like retain those nutrients and really provide all those benefits that we saw earlier. And this is kind of like in this context is what created the Cover Crop Initiative, which it is a partnership between the University of Nebraska, Lincoln, and NRCS. And the whole objective of this partnership was to establish replicated randomized cover crop variety trials to be able to identify species and varieties or cultivars that were better suited to the different parts of the region, Nebraska regions. We also wanted to estimate biomass production using the Nebraska specific climates, soils, and species data. It is it's common to see, you go to a literature review and you see all of this variability of what to expect in cover crops or their biomass production. And unfortunately, that depends a lot on weather. So we wanted to have more specific climate information, at least to be able to target and give better recommendations. Another objective was to train NRCS personnel and stakeholders on implementing site-specific cover crop projects that would align with management goals. And last but not least was to facilitate interdisciplinary collaboration among researchers, extension educators, farmers, and conservations on this cover crop benefits and expectations. So for this particular project, the Cover Crop Initiative, we had 6 different locations and 3 different planting windows that we were trying to target. And we had like the spring planting, fall planting, and summer planting. Not all of those locations had all 3 planting windows, but we normally had around 2 to 3 locations per planting window, just so we could get like a better idea throughout 2 to 3 years of the experiment. Okay, now we're going to go and start talking more about the spring planted cover crops. And for this specific study, we did it in 2 different locations, which was Sydney in the High Plains Agricultural Lab. The environment was a dry land, no-till field with Keith silt loam type of soil texture. And in Scottsbluff, the Panhandle Research Extension and Education Center, where again we also had dryland no-till with trapped sandy loam soils fields. And again, this is the spring planted cover crops more targeted to the west side of the state because of their very harsh winters and very, very short window. And for this study, we evaluated 7 different grasses, 4 legumes, 3 brassicas, and 6 mixtures. 3 out of those mixtures were two-way mixes, so they were normally 1 grass and 1 legume, and 3-way, which was 1 of each, like grass, legume, and brassicas. For the the experimental design of this particular study, we had a randomized complete block designs with 4 repetitions and the 20 different cover crop treatments. All of our plots were around 30 feet to 5 feet. Yeah. Now, our planting window again started early March all the way to early April. It was very depending on how the winter was or like when the spring really started ideal to be able to plant. But we will try to plant as early as possible. And in Scottsbluff, we planted after corn. And in Sydney, we planted after sunflower and wheat. The seeding rates for all of our cover crops were grasses were 100 pounds per acre, legumes was 70 pounds per acre, brassicas 8. Our two-weight mixtures were half of its sold rate, so 50 pounds per acre of grasses and 35 pounds per acre of legumes. And for the 3-way mixture was 1/3 of its sold rate. So it was around 33 pounds per acre of grasses, 23 of legumes, and around 2.5 pounds of brassicas per acre. The parameters that we measured throughout the study were plant counts, mainly to get an idea of early establishment, plant height for above ground productivity. We also did some ground cover, the dry biomass, which we use for above ground productivity and also to run some forage nutritive values. And last but not least, we also did some biomass carbon and nitrogen. And that was mainly to assess the residue quality of the cover crop. Termination happened in mid to late May in both of these locations, right before planting our main cash crop. And our biomass was just taken by using this 2 feet square quadrant that we would place in a representative part of the plot, and then we would cut all of the biomass of the above ground. So the total growing window for 2022 was 81 days in Sydney, 62 days in Scottsbluff. And in 2023, we had 60 days in Sydney and 76 days in Scottsbluff. Now, to share a little bit about our results, this is just to give you an idea. This is the cover crop biomass range between between plant families, sorry. So something that is very interesting is like we had a very increased biomass ranges or like higher biomass range when it came to our 2023 study compared to 2022, sorry. And we attribute that to the precipitation that we saw during the growing window, the cover crop growing window. In Sydney, we had an increase of almost like double the amount of rain in our precipitation in 2023 when compared to 2022. And in Scottsbluff, we had almost like 3 times more precipitation in 2023 than 2022. So grasses in Sydney on that first year range between 42 to 800, almost 900 pounds per acre. Legumes between 9 to 1,200. Brassicas were a little more like in the less amount of biomass between 0. We had plots that nothing grew to 200 pounds per acre. And mixtures did around 116 to 700. I would say was a little bit more stable in that lower range. Now in the second year, we found grasses did between 300 to 3,000. That's a very big range over there. Legumes did between 160 to 400, almost 500. Brassicas between 24 and 500. and mixtures between 200 and 1200. Now, Scottsbluff, we kind of saw that same pattern of having higher biomass on that second year, with grasses having a range of 84 to 700, legumes 53 to 400, brassicas 4 to 52, so it was still very low. Mixtures between 44 and 600. And in 2023, we see like again an increase. We see 150 around to 1200 from grasses. Legumes did between 10 and 370. Brassicas between 53 and 450, and mixtures between 110 to 1200. So that increase. Now, I just highlighted kind of the range between years. So we had the lowest number of biomass production was 0 in Sydney in that first year, and the highest was 1,200 pounds per acre. And in the second year, it was between 24 and 3,000 pounds per acre. In Scottsbluff, we saw 0 to 700, so less than we see in Sydney, and between 10 to 1,200 pounds per acre, which is again still a lot less biomass compared to Sydney, Nebraska. And I just wanted to highlight this to show how large or like just how different our biomass can react depending on not only the families but overall between years and in years. Now, our top species for both locations, we had Sydney and Scottsbluff in 2022, oats, dairy oats, pea, and our two-way oat pea mixture. And in Scottsbluff, we had triticale, again, jerry oats, and Lavina barley. And in 2023, we see again jerry oats, Lavina barley, and robust barley, and a three-way mixture of barley, pea, and rapeseed, and barley and Lavina barley. So a little bit of the patterns that we saw about the spring planted cover crops. We see a lot of stability when it comes to jerry oats for especially Sydney, as it came up as the top producing for both years, but also in Scottsbluff because we see it in the first year. And barley Lavina, although it did not do as a top producer on either year, it maintained the third place in both locations. So it is, if you're trying to say like a safe option, this is the patterns that we found and we saw here in the spring planted cover crops. Now, for the fall planted cover crops, we had 3 different locations for this one. The first one was in eastern Nebraska, Concord, in the Haskell Agricultural Lab, which was dryland, no-till, with moody silted clay loam soil. Then we had the North Platte, which is central Nebraska, which was a dryland, no-till, Holdridge silt loam soils. And we see Scottsbluff once again for western Nebraska with dryland, no-till, and sandy loam soils. For this particular study, we had 30 different fall planted cover crops. We had 11 different grasses, 6 different legumes, 5 brassicas, and 11 mixtures. And this is where our mixtures became a little different. So we had a couple that are 50-50 mixtures, and we also found some 25-75 mixers. So 25% of the grass and 75% of the legume. And this was mainly to try to see if that would improve or if we would have more legume biomass and not only our grass biomass by the end of the growing period. For experimental design, follow the same as our spring planted cover crop. So it was 4 repetitions, 30 treatments, and the plots were 30 feet length times 5 in width. Our planting dates varied on this one. So we had some hand broadcasted in Concord in early September. It was interseeded into corn, and then we drill planted in North Platte and Scottsbluff in mid to late September. And in North Platte, it was after wheat harvest, and in Scottsbluff, we had it after sunflower and field pea. The seeding rates for this one follow kind of like the same idea of our spring planted cover crops. We just added extra for the hand broadcasting location. So grasses were between 100 and 150, peas were 70 because they were only planted in North Platte and Scottsbluff. Hairy veg was between 30 and 45 pounds per acre, brassicas 8 to 12, and our mixtures follow the same idea. Half if it's sold rate, unless it was a 25-75 mixture, and our three-way mixtures were 1/3 of its sold rate. For this particular study, we had a lot more parameters that we measured. For the above ground ones, we did plant counts, plant height, ground cover. We did some shoot and root biomass and also biomass carbon and nitrogen, as well as some weed biomass. Our soil biophysical chemical parameters were bulk density, gravimetric water content, texture, pH, electrical conductivity, total soil carbon, and some more biological, such as potential carbon mineralization, potential mineralized nitrogen, phospholipid fatty acids, and beta-glucosidase. Again, we're just going to focus right now on our biomass production. So termination happened between mid-May. We're early to mid-May. We really tried to follow or not hinder the cash crop planting. And this meant that in Concord, we had in the first year 8.3 months of growth. In North Platte, we have 7.5, and in Scottsbluff, we have 7.7. And in the second year, we had again 8.7 months of growth in Concord, 7.9 in North Platte, and 7.7 months of growth in Scottsbluff. Again, we just caught the biomass and then dried it. And for these locations, we saw, again, the same. 2022 to 2023 was a drier year compared to 2023-2024 season, and the water affected how much biomass we had on the field, right? So, gonna skip. This is a very long one, but highlighting again, the ranges range from 3 of brassicas, which is the lowest producing plant family, to 2,600 for grasses, which is the highest producing one in Concord for the first year. In the second year, brassicas again, 0, and this time mixtures came up as with 11, almost 12,000 pounds per acre of biomass production. In North Platte, brassicas again did not produce. They actually didn't produce anything in North Platte and Scottsbluff for either of the years on this study. So the highest production was grasses with 2,500 in the first year for North Platte and 3,500 for the second year. And Scottsbluff, it was 0 again to 4,400 in the first year, and from 0 to 11,000 pounds per acre in the second year. And I know this is a lot of information, but I want you guys to just focus on like the patterns now. When in Concord for the first year, we had Elbon rye as the top performing species, then which Elbon rye, we again saw it as a top performing species in North Platte in that same year. And that kind of followed during the second year for both Concord and North Platte, although this time Elbon rye became like third best performing, and in North Platte it was the first top performer. Scottsbluff, we didn't see a lot of Elbon rye until that second year, but we did see the two-way mixture of rye and hairy veg, the 50-51, as top 3 in the first year and also top 3 in the second year, showing that it is still very I would say like stable if you want to choose a cover crop to use in this location. So in summary, what do we learn from at least this like very snapshot of this 4-year long partnership is that cover crop species perform very differently depending on the planting season. And it's important to match species to planting windows to improve outcomes. We saw that Jerry oats was the top performing spring cover crop for biomass in western Nebraska. Elbun, Yankee, and Hazlet. So all rye varieties, when fall planted, showed very strong adaptability and high biomass across Nebraska. We saw that biomass range, rather than just focusing on the average, we should focus more on the overall performance on the ranges because it provides a better understanding of the potential that these cover crops can have. And then weather variability between years significantly impact cover crops, biomass, even when planting dates remain constant. Realistic biomass goals are critical, especially in areas with low precipitations or harsh winters that limit growth. And finally, we have that using local data to guide species selection and management is key to optimizing biomass production. Some more project outputs that we've had, if you are interested, we've wrote a bunch of crop watch articles. We have some cover crop variety test results also. We have an educational module regarding cover crops and a little bit of what we found. We have all of our data in a public database that you can access if you want to see or like play around with it a little bit on your own. And we also have a cover crop biomass calculator, specifically for Nebraska too. If you just right now, if you want to get like an idea of when do I plan and when do I terminate, what can I expect? We've also produced some fact sheets, photo books, short videos, and peer-reviewed journal articles, etc. From this like 4-year-long project. And well, that's it for right now. Thank you. Any questions?
Well, thank you so much. Folks can go ahead and put questions in the chat. And if you want to go ahead, Grace, and send to the next slides, I'll get through those while people are getting their questions in the chat box. So if you attended today's webinar and would like to earn a CCA, CEU, or continuing education credit, please send the following information to Elena Whitaker. That's ALENAW at iastate.edu by 5 o'clock today with the name you used to watch the webinar, if that's different, and your CCA or other organizational number, and we'll get that submitted on your behalf to get that credit. If you want to go to the next slide for me. Oh, there we go. So this is probably not new if you've joined us previously, but we do have a voluntary demographics survey that we're asking folks to fill out just once a year. If you've done it for the 2025, thank you. If you have not, you can scan that QR code there on the screen or simply visit iowalearningfarms.org/survey. Again, only one response is needed, and we appreciate those that have completed that for us. You can always join us Wednesdays at noon. If you want to go ahead and click to the next one, we'll get a preview for what we are going to hear about next week. Our slides will advance here. There we go. Elliot Anderson is an assistant research scientist at the University of Iowa, and he's going to be discussing quantifying Iowa's annual phosphorus budget. And I know there was a question that came in asking about the presentation. So if you want to go ahead and click to the next slide, all of our webinars, including today's, have been recorded and uploaded to our website. You can find that at iowalearningfarms.org/webinars. You can also find them on a YouTube channel. So if you go to YouTube, you can search Iowa Learning Farms webinars. They're sorted by topic and year into playlists, so you can find all the cover crop related things or other topics that may be of interest to you. So let's jump in with some questions here. So the first question talks about adjusting the cover crop mixes. So did you find that the mixed cover crops could have been adjusted differently instead of like the 50% of the solo rate to account for particular species aggressiveness?
Yeah, it's a great question. Unfortunately, we didn't adjust the seeding rate. Rather than we just used, for example, for two-way combination, we use the 50% of the sole seeding rate. And for three-way combination, we use the 33% of the sole seeding rate. So we just adjusted accordingly.
And so questioning here about the increase in your Nebraska biomass, specifically from 2022 to 2023, you noted was related to rainfall, but could it also be that you're likely to see that increase until the second year of using a brassica?
So in our case, all of the our cover crops weren't planted on the same field every year. It depended on the availability of the fields because of the rotations. So it was like a unique field. So this is a very 1 year, how did they perform the year that they were planted. So we can tell that it is directly because of like the weather and not because of that second year effect, let's say, on like residual or leftover planting seeds.
And there was a question, you noted that you've published a few related journal articles. So there was a question here about being published. And it looks like Vesh noted that so there's some work in progress. So where might folks be able to look for articles once published?
As Grace mentioned in her presentation too, so we have a bunch of crop watch articles already published. But if you're really talking about the scientific journal articles, so one of our manuscripts related to spring cover crops is under review with the Agronomy Journal. So we are hopefully getting it published soon, and rest of the manuscripts are under preparation.
Question about the cover crop termination method. Was it always herbicide, or did you play around with any other methods like crimper or tillage, brush hog, things like that?
Mostly they were just chemically terminated.
And what was your method like? What did you use in application rate, if you remember?
We use glyphosate for
Okay.
termination. Yeah, and then I don't exactly remember the exact figure on top of my head right now. But yeah, we use the minimal rate of glyphosate for termination.
And kind of looking big picture, this 4 year study looking at these different planting times and things, do you see any possible policy implications from the work that you've done?
Yeah, definitely. I mean, one would be like, since one size does not fit for all, so when you talk about cover crops, so be specific on what kind of species you can really perform to your local conditions. So that could be like, one of the policy implications from this project. And maybe Grace, if you have something to add on.
I think it's because we've also been working with NRCS. This also helped them see how variable cover crops are. And that is a very important thing that we really want to. Yes, it's good to have a range and you have like an idea of expectations, but at the end of the day, cover crops depend so much on weather and residual like residual nutrients in the soil from your previous cash crop. You don't fertilize them. They're not meant to grow ideally in ideal conditions, let's say. So we've seen, like, for example, if you have, some policies with NRCS or some cost share programs, there'll be like, okay, you cannot terminate the cover crop early, or you have to have this amount of biomass. This is just a way to show you won't always reach that potential or like that highest biomass. And also, if it's a very dry year and you have fall planted cover crops, it's okay to terminate early if you need to leave some water in the soil for your cash crop, right? So we're hoping that this is just given also the rationalized part of it, and like the lid review helps a little to the policymakers, maybe more than the policies, like in that flexibility, let's call it, when making cost share programs or having certain like conversations with farmers, so that yes, they're great, but you can also use your rationale and be like, I need to terminate early if it's necessary, and it's fine. And it hopefully they won't be penalized because of that, um, using this type of like information.
Yeah, and then I would like to just add on, Grace. So, especially for Western Nebraska and similar agroecosystems worldwide, so we are pretty dry, and a lot of the time people talk, okay, cover crops won't do great in the dry regions, but do we really have data to support that perceived things? Like, do we have enough data to on that, or do we have enough cover crop options so that people can tailor their management practices accordingly? So our our goal was just to see, like, can we really harness the benefit out of those short windows? So we are just trying to provide a variety of options, whether that can really perform in that growing windows and then in that local dry climate. So
And I know that a lot of this information is probably also helping advise the Midwest Cover Crop Council's cover crop species selector tool, that is free for folks to use all across the Midwest. So you can put in your location and county and find information and recommendations for what can work and meet your goals there. So a quick shout out to them. Um, and yeah, so I would agree. There was a compliment here to you both, or maybe Grace, whoever pulled together the slides, but they really appreciated that they were not too cluttered and lots of graphics. And they're just curious where you got some of your images.
Oh, okay. Thank you. I do enjoy making things look pretty. Um, a lot of the icons I get from Flaticon, which is like a online icon location, but others I did myself. So the isometric fields I did myself using Adobe Illustrator. Um, and some of them I've just, for the sake of consistency, I've edited a little bit on my own, and mostly in PowerPoint. So, but if you want the icons, you can find them in Flaticon. That's like a good place.
And so maybe this is the next steps for this project. Do you have any cost benefit analysis associated with some of these cover crops? Often we hear that, profitability is a big role in cover crop,
yeah,
adoption.
yeah, we do have all the economic data associated with the project. So we are working with economists on that aspect too, but we don't have exact figure right now to tell.
So
Yeah, but
stay tuned. We can have you back to talk on that side of
yeah.
this project. So thank you both. If there's any final questions, folks can get those submitted here in the chat. Again, feel free to check out this archived webinar and all of our previous ones on our website or our YouTube channel. Thank you so much, Grace and Vesh, for your presentation today. Any final comments or questions? All right, so it looks like even here in Southeast Iowa, Southern Iowa, where we do get more moisture, they found this very helpful. So thank you so much. I'll leave the final word to either Vesh or Grace.
I just want to say thank you for having us over and sharing a little bit of this very extensive and crazy work. We're sorry we can share a lot more right here because it is a lot and it's a very short window and we don't want to bore you. But please reach out if you need anything or you have more questions regarding it later on. And I just want to say, keep in mind, cover crops have a range. Let's get out of that average completely mindset, at least when it comes to cover crops, because you can just do it dirty. I feel like if you have a range, you can better expect or have better expectations. And if you have a very bad year and things don't go great, the disappointment won't be that much. And if it's a great year, you're going to be very excited and happy about it. So, yeah,
Great point.
thank you.
Thank you so
Yeah,
much.
Yeah, I also want to say just thank you for having us here, and we're happy to share our findings from the projects. And yeah, feel free to reach out if you want more information on the projects. We are always there to share our findings with you all.
Wonderful. Thank you so much. Have a great afternoon, everyone.